Hello everyone, this is Dr. Sushmita Yadav. Welcome once again to my channel Orbital. So guys, in last lecture we have learned about how many type of the organic bases are there, how to check their basicity. So this lecture is in continuation of that. Here we are going to detail first the aliphatic amines, then aromatic amines. So aliphatic amines means they are the derivative of ammonia, and journal formula on depending upon the R group of the present in ammonia, each hydrogen will be replaced by the R group. Then depending upon how many alkyl group are present there, they are of three types: primary amine, secondary amine and tertiary amine. Likewise, we can write it, this is primary amine, secondary amine and the tertiary amine. So if we compare their basic strength with ammonia, then what should be the order? The order should be, we learned, because as the electron density of the nitrogen increases, its donor capacity will increase, and that means the basic strength must increase. So the order should be like primary amine should be less basic, because R group means it's going to be the alkyl group, maybe methyl, ethyl, propyl, anything. So when the R group increases, plus I factor is going to increase, and the plus I increases from this to this direction. That means the basic strength increases, and I should write it at the least one, ammonia. So what is the basic strength order should be? Tertiary, secondary, primary and ammonia should be the least basic. That means tertiary, secondary, primary and then ammonia. But here is a big difference in the explanation. This order is true only in gaseous phase. Only in gaseous phase. So what we can write? In gaseous phase you are having your order 231 and ammonia is at the last. Okay? The order is 321 at the gaseous state. Gaseous state means whenever it is clearly mentioned you in the question that the particular compound is in the gas phase, then only you will follow this order for the basicity 321 order. But whenever this compound is dissolved into water, then the order does not remain the same, it changes. In water, the order remains, in aqueous solution, the order remains 231 and the ammonia at the least. 231 means secondary amine, tertiary amine, primary amine and then ammonia. This order is true in aqueous solution. In aqueous solution, you need to follow, if you are provided by this, so which should be the most basic? This should be the most basic, then this one and then this one. What is the reason? I will give you explanation in detail, don't worry about that. Now, here is again one more very important case. This is the order you need to follow all the time with aliphatic amine in aqueous solution. And mind one thing, till the time you are not mentioned clearly in question that your amine is in gaseous phase, you will always consider the amine solution. Okay? That means if gaseous state word is not there in your question, you will follow this order. So most of the time question will come over this order. This is only a special case of the gaseous state. Correct? Now here also, if all R group are methyl only, then your order will further change for the primary amine, secondary and tertiary. For example, I am writing the secondary amine means CH3 whole twice NH, then primary, I am writing then tertiary and then primary. So if you are having this one, means all the R group are methyl, then what would be your order? Your order will change from this also. In aqueous solution, your order will become 2, 1, 3. That means secondary, primary and tertiary. That means here if I am writing A, B and C, then A will be more basic, then C, then B. This will be the order. Okay, so remember this as a special case. So this is an important point you need to remember. If your R group are not methyl means there are some other group also, then always follow this order. Most of the question you will get over this also. But remember the exceptional cases. Means in the gaseous state 321, and when all the R group are methyl, then you will follow 213 order. Okay. Now, what is the reason of these orders? The reason of these order, and this order is also in aqueous solution. Okay. Because when you are in the gaseous, you will not follow any of these, you will follow simply this one, 321 order. Correct? Now, what is the reason of all these order? If we go for the aqueous solution, this, why it is not going to be the similar like the gaseous, like why it is not like tertiary is more basic than secondary, than primary, then there is an explanation for that in aqueous solution. In aqueous solution, basically just consider, let's suppose you are having this amine. Okay, ammonia is having, ammonia you can take ammonia as well. Ammonia or aliphatic amine, they are having the lone pair over the nitrogen. So from aqueous solution, they will take up the proton, and the proton will be taken up by this lone pair. As a result, they will form a cation. After that, they will form a cation. Okay, and here remember the stability of this cation, because stable the cation, stronger will be the basic character, means it can hold the proton for longer time and will show the basicity. So stability of this cation, stability of cation depends on two factors. One is the plus I group attached to that. Another is the stability given by the water. Okay, so there are two factors of stability of cation formed after gaining of the proton. One is the plus I group, which is giving the stability to carbocation by donating electron. Another is the stability by the solvation stability by water. So these are the two governing factors for the stability of cation formed after the taking up proton in aqueous solution. Now, if we compare primary, secondary and tertiary amine, for example, this is the primary amine. Ammonia will be the least one. This is primary amine, this is secondary amine, and this is, let's take tertiary amine. Okay, they are having positive charge over the nitrogen and one more hydrogen is there too attached. I am just going to compare about the stability of this cation. So in this case, the plus I, this is the primary amine cation. So this is primary amine cation. The stability is increased by plus I. The R group is causing plus I. Now, as well as these hydrogen were stabilized by the water. Oxygen of water will come to solvate them. And more the solvation, more will be the stability. Okay, so that means here the two factors are working for the stability. One is the plus I of R group, second is the solvation by the water. Correct? Now, if we compare the same thing here in this, the plus I increases, but see the molecule in such a way that along with the plus I increase, R group is bulkier group. So crowding also increases. So in this case, the attraction towards water will face a problem. That is the problem because of crowding. So in this case, the steric hindrance to water, that is called SH2H2O. That is the main phenomena. This is steric hindrance to water will be more than the earlier one. Means here water was coming normally to solvate the proton. But here water is facing difficulty to come in comparison to this because of steric crowding by these R group. As a result, here the two factors are going. The solvation was increasing the carbocation stability, but the hindrance to solvation will decrease. So, steric hindrance to water is a base weakening effect. Base weakening effect means more the hindrance means lesser the solvation. If solvation is lesser, then one supporting factor is going to be negligible. So only one factor will govern the stability of cation. Okay, so here the two factors are working together. One is the plus I and another is the hindrance to water. And in that plus I and hindrance to water, the plus I dominates in case of the secondary amine, and that's why it becomes the more basic in comparison to the other one. Now here, in this case, there are too much of the plus I and as well as too much of the steric crowding, because as the plus I increases, crowding also increases. So here the hindrance to the water will be maximum, and in this case the hindrance will be so much that it will dominate over the plus I, greater than plus I factor. That's why its basicity decreases. So if we compare all those three, then secondary comes out having a balancing forces, because one factor supporting, another factor opposing, and in this supporting and opposing factors, your supporting factor dominates. Here your opposing factor dominates because you are giving a lot of hindrance to the water because of high steric crowding. So what is the order going to be? Order going to be in the secondary, everything is balanced in such a way that it's going to be more basic in nature. Two forces which are going to be supportive and opposite to each other for the cation, plus I factor in all the structure, and if we compare this and this, the plus I factor of the primary amine is lesser than the secondary, so primary will be less basic because this factor supports the basicity, and hindrance to water oppose the basicity. If the hindrance here is the plus I factor is minimum, and here plus I is better than the primary, so I factor is better in this, and hindrance is balanced, it dominates over the hindrance. Here the hindrance dominates over the plus I because crowding is too much. So overall resultant of these two forces, SH2H2O and plus I, the resultant of these two forces in the aliphatic goes like that, and the order becomes 231. Correct? So likewise we will follow this order whenever we are having the amines questions to do. I will take some examples next to clarify the concepts more. Yes guys, let's see some examples of that. Now the first one, these three examples are there. This is a primary amine. What is the hybridization of nitrogen there? sp3. Here it is the amine where the nitrogen hybridized by sp2. What is here? The sp hybridized nitrogen. So what is the impact of hybridization? We all know if the S character increases, S percentage increases, electronegativity of atom increases. Now, if the electronegativity of atom increases, its basic strength will decrease because it supports the acidic strength but opposes the basic strength. So here, which is going to be the good base? Because here as the electronegativity, which nitrogen is most electronegative? The sp nitrogen is most electronegative because there is no resonance, no other phenomena is working here, only the degree of nitrogen will be your key concept to solve this question. So here as the percentage of nitrogen, as the percentage of S character increases in the hybridization, then Kb decreases with increase in electronegativity. So this nitrogen is most electronegative, that means it will be least basic because electronegative atoms do not donate their electron pair easily, and the donation capacity is only the factor governed by the basicity. So here the lone pair will not be donated in comparison to this because this nitrogen is more electronegative than the other nitrogen. So what will be the Kb order? This will be simple Kb order on the basis of electronegativity of nitrogen. So whenever question will come, look at the question carefully on the behalf of which factor the question is being asked. You need to identify that first. Like in the second question, this is a nitrogen which is going to be resonance. Okay, that means here is the resonance. What is the hybridization? That means your lone pair is going to be delocalized. Lone pair is delocal. Delocal means it is delocalized during the resonance. That means not truly available for the donation. In the second one, it is getting only the plus I factor, no other factor is there, so lone pair donation would be quite more easy. And this one is primary in nature, and this one is going to be, this is hybridization wise sp3 hybrid, and this is hybridization wise again sp2 hybrid. Now among these two, this is again lone pair is local. Local means localized lone pair which is available at its position for the donation. So these two are having the localized lone pair, that means their donation capacity will be governed by some other factors which are going to be the point of difference between these two. This is sp3 hybrid, this is sp2 hybrid, so definitely this is going to be the top one because it's going to be the least. Here the lone pair is delocalized, means going to be a part of resonance, so not will be available for donation. So if we write the order, then your second one is going to be more basic, then third one, and then your first example. Correct? So this is, I am writing like this is first, second, third example. Likewise. Done? Now, the next one here, if you will see, in all of these there is no resonance phenomena is applicable, only the structure of the ring is given, but there is no conjugation, so all the lone pairs are local. Localized, that means they are available for the donation. Now let's check their degree first. What is the hybridization of nitrogen here? It is degree wise secondary nitrogen. This is degree wise tertiary nitrogen. This is degree wise primary nitrogen. And what we learned about when no other factor is working, then go for the normal order. What we learned in the aqueous solution, the order will be 231. 231 will be, means the secondary will be more basic, then tertiary, then primary. Correct? Now, in the same question, there are the three nitrogens available. How to compare their basicity? The same phenomena we will apply here because there is no conjugation, no resonance, no delocalization. So just go for the degree simply. This is primary, this is tertiary, and this one is secondary. So again, your Kb order we will form. 231 order means secondary will be more basic, that means C will be more basic, then B, and then A. So likewise we will study in the questions. First you need to identify what is the point of difference between the compound is given. If you will go directly for that point of explanation, you can write it directly. Now one more case here, nitrogen is of same type. The degree of nitrogen in both the compound is same. This is tertiary, this is also tertiary. But the difference is this is a cyclic system, means nitrogen is a part of closed ring and it is an open system or acyclic system. Correct? So whenever you are having this kind of example, cyclic and acyclic, then always remember Kb for the cyclic is going to be more in comparison to the open or acyclic system. What is the reason? Reason again goes to the steric hindrance to the water, because it is a closed circuit. So all the groups will lie only one side, so will create less hindrance to the coming water in comparison to this, because here the group will be available in the different directions and will cause the more hindrance because of more steric crowding. So these are few examples for the aliphatic. Rest is your practice as much as you will do. You can even send your doubts to me in the comment section. And now the next topic we are going to take last in this case, aromatic amines. We will start with the aniline and the derivative of aniline. Okay? Yes, now in this section we are going to discuss about the aromatic amines. Aromatic amines means aniline and their derivatives. What is the aniline? Aniline is having the benzene ring with NH2 group. So here you can see clearly the lone pair of aniline is going to be a part of resonance. So we can write the lone pair is delocalized. Okay. So if the lone pair is delocal, it is not available truly for the donation. So if we compare this aniline with the aliphatic amines, then aliphatic amine, the lone pair is local and available for the donation. Rest of the nitrogen condition is similar here. So we can say clearly that aromatic amines or aniline are going to be the less basic than aliphatic one. So this is one concept. Now, if we compare about the aniline in the different phases, because in the aromatic part what can happen? We can have the ortho, meta, para derivatives of the aniline. So if there are two kind of group may have present over the aniline, whether EWG group or whether ERG group. So if EWG group is present, EWG group is present on the ring, then EWG group means either at ortho, meta, para. Ortho I will take specially again, because like the carboxylic acid, ortho will have some impact in the aniline as well for the basicity. If EWG group is present, so EWG means the group must be minus I or minus M. Group means electron withdrawing in nature. So these group, if present at the ortho, meta, para position, they will withdraw electron from the ring. Ring will become deficient, so ring will hold this lone pair more quickly. That means if the EWG group increases, KB decreases, we have already learned, then EWG group increases, it will decrease the basicity. Likewise, we can compare with the ERG group here. If ERG group means electron releasing group, either plus I, plus M or plus hyperconjugation is present, they will give electron to the ring. Ring will become more rich in electrons, so lone pair will be not much needed by the ring. That's why the basicity will increase. So over and all, we can say in comparison to the simple aniline, the derivatives having EWG and ERG group will have the different basicity. Means any group with ERG, we can write simply any ERG group if present, that will be more basic than the simple aniline as well, and that will be again more basic than the aniline having EWG group. Correct? Now, these group can come at ortho, meta, para location. Now, depending upon that, we can take some example, but before that, I want to tell you what is the impact of EWG or ERG on the ortho position. Here also, the ortho effect will work, but it is not called ortho effect, it is called steric hindrance to water, that we already learned in the aliphatic section. So it is said when any group means either EWG or ERG. If any group is present at ortho position of the aniline, then this group will create a steric crowding here. Because of that, this group will increase the steric hindrance to water, And I already told you, if steric hindrance of water increases, then Kb decreases because it is a base weakening effect. So simply, any group, whether EWG or whether ERG, it is similar to the ortho effect we did in the organic carboxylic acid section. They increases the acidity, but this decreases the basicity. So here, if any group, whether EWG or ERG, irrespective of its nature, it's going to decrease the basicity. Now let's compare. This is the core concept of the basicity in the aromatic section. We'll study all those things by taking some example. For example, if similar type of example like we did in the carboxylic acid, on the same behalf we will explain all this. For example, this one. So here, just write down what are the effects or what are the nature of the group. This is the plus hyperconjugation plus I and SH2H2O. The effect is called not ortho effect. The effect is called SH, steric hindrance to water. And steric hindrance to water is there. That means basicity will decrease. At the meta position, it will cause the plus I only. That too will be very weak. Hyperconjugation will not work at this location. Here again hyperconjugation and plus I, but hyperconjugation will be the dominating effect. So now we can compare what is there. There are more factors who are supporting the acidity, basicity in comparison to this or not. Just tell me. If we compare all these examples, then we can simply check here. The order for this will be better, means the Kb strength of the third one will be greater than the first one, because in the first one other factors are along with the other factor, your SH2H2O is working. So any group present on the base ortho position will decrease the basicity. So we will take the same concept here, then your meta position, and then third, second, and then your first one will come. Likewise, this effect is going to decrease the basicity. It will be less basic than the simple aniline. Correct? So just remember, any group, either ERG or either EWG, they will decrease the basicity. So let's take some more example and finish up this topic. Yes guys, let's see some examples. Now in the first one, the order of Kb we need to set. There is the Cl group attached. What is the nature of the halogens? Halogens have a minus I and plus M effect. But these are exceptional case in which the plus I dominates over the plus M. Okay, so whenever halogen is there for the ortho meta para position, just consider their minus I effect, because their plus M, their minus I dominates over the plus M. And minus I, we know it is a what kind of group? EWG group. So minus I effect will decrease the basicity. So in all these, this is going to be the most basic. And one more thing here, at the ortho position, it again decreases the basicity by doing the steric hindrance to water. So now let's make the order of Kb. What will be the Kb order? The fourth one will be the most basic. Then as the minus I decreases, because minus I is a opposing factor to the basicity. Lesser the minus I, better will be the basicity. So minus I is a distance dependent effect. So it's going to be the weak at the fourth location, then third location will be better, and the first location will be strongest. And first location again having the steric hindrance to water. So I hope the order is clear to you. Now it's going to be 4, 3, 2, 1. Okay. Now in the same way for this one, here just identify the group and make the order. NO2, what kind of group? Strong minus M and minus I group. Okay. And this is OCH3 is a good plus M group and minus I, but plus M dominates. CH3 is a hyperconjugation and all the groups are at the para position. So here hyperconjugation is also a donating effect. So two groups are the donating means ERG, one is the withdrawing group means EWG. Which factors support the basicity? ERG factor. Among these two, which is the stronger effect? Mesomeric effect or M effect is stronger than hyperconjugation. That means it is a better donor than the CH3. So this will increase the basicity because we have learned ERG increases, basicity increases. That means second is going to be more basic than third and first will be the least one because it is having a EWG group. Now, in this case, by nature, these two nitrogens are secondary in nature. By nature, they both are secondary. But there is a big difference if you will see clearly. This nitrogen is aliphatic and this nitrogen is aromatic. Why aromatic? Because it's going to be part of resonance with the ring by donating electron pair in this way. Okay, and we have already learned that aliphatic amines, when the degree is same for both, aliphatic amines are going to be more basic than aromatic amine. So if we write it nitrogen number 1, nitrogen number 2, so the Kb for the second will be greater than first. Correct? Now next example for this one. This is your aniline. This is pyridine and this is pyrrole. It's a very common question. In aniline, now let's check their nitrogen in all the three. Aniline nitrogen is going for the lone pair to the resonance, means lone pair is D-local. Correct? In the pyridine, it is already having a conjugate system of the 6pi electron. So this lone pair is not going to be the part of resonance, otherwise it will become the anti-aromatic. So molecule will not do something like that which will decrease its stability. So what is the lone pair here? Lone pair is local. So when the lone pair is local, that means the pair of electron is easily available for donation. Here again, it is going to be the part of system, and when it is going to be a part of system, that means to attain the aromaticity, it must be taking part in resonance just to complete the 6pi electrons. So here the lone pair is again D-local, and that means not available for donation. So among these three, this will be the most basic. If I write them number 1, 2 and 3, so pyridine is going to be the more basic than pyridine, that means number 2 is going to be more basic than aniline, number 1, and here it is least basic. The reason is that your lone pair is not only the part of resonance, but it is contributed just to complete the 6pi electron system condition for aromaticity. Okay, so this lone pair is not considered as a lone pair here, it is a part of conjugated system. So it's going to be the least one. So it is in theory, just remember, pyridine is more basic than aniline and pyridine is more basic than pyrrole as well. And this is the order of all those three. Now in all these cases, if you will look carefully, this is a guanidine example. And I already told you guanidine are the strongest bases. This is guanidine derivative, correct? This is amidine derivative. And for this you all know it is aniline and it is pyridine. Now, what should be the order? I think no need to tell you. The order will be guanidine, 1, 2, 3, 4. The guanidine will be the most, then amidine, then aniline and pyridine. Who is more basic? Right now we did it. Pyridine lone pair is local, aniline lone pair is D-local. So definitely your fourth and then 3. So guys, these are few examples, but it is not the thing that examples are over. You need to practice a lot more examples to understand the concept clearly. Because more the practice, more stronger will be your concept over this. And give me your comments for the feedback, and also you can give me comment for if any topic you need me to do in the next lecture, then you can send it to me in the comments. I'll make the video over the topic. Hopefully it is good to you. So see you in next lecture. Thank you so much.